All right, so today I'm going to be going through my RET experience with you guys and kind of doing a little presentation on what kinds of things I was doing research on at Clemson this summer, or I guess this past summer. And then I'm going to go through my teaching module that I came up with. And then lastly, just some takeaways from the program, things that I enjoyed, that kind of stuff. So to start, I'm going to get into the research process and what kind of things went into that. Um, so before I get started with that, I do want to talk to you guys. My whole research was done on tourniquets and kind of the effectiveness of what a tourniquet is. Now, I realize not everybody has heard of a tourniquet, so I do briefly want to talk about the function and the purpose of tourniquets. So the whole purpose of a tourniquet is to stop the flow of blood through somebody's veins or arteries. And typically, this is done by wrapping around some sort of cord or bandage around somebody's limb and occluding the blood flow or stopping the blood flow. Um, so, I guess the question that comes from that is why is researching a tourniquet beneficial? So, there's a few things. We can help find ways to make the use of tourniquets a little easier and simpler to understand for people in emergency situations. And then also, there's a lot of research that's been done to see or try and limit the damage that tourniquets can actually do to somebody's limb. Because sometimes, if people tighten them too tight, you can actually cause nerve damage or tissue damage. So, like what kinds of cuffs work well, what is the best tightening mechanism for the tourniquet, that kind of stuff. So that's a lot of ways that researching these types of things can be beneficial. So here are some of the research focuses and motivation for the research. I did kind of touch on them a little bit, but basically we were trying to see if there was a way to measure the effectiveness of a tourniquet. So this company sent Dr. Desjardins a testing device to use to test the effectiveness of tourniquets. And we were kind of evaluating that testing device while also testing the different tourniquets. So another thing we were seeing was, is this testing device, which was a simulated leg, it was an air bladder, a black air bladder, is this testing device an effective measure of how well a tourniquet is actually working or doing its job? So we were kind of looking at that aspect of it too. And then the last piece of it was, are there ways that we can make this testing process a little bit easier or standardized so that way we know what we're supposed to be doing each time? Before we actually started doing research, I did go through some of the literature and get a few key points from there. The main one is I understood or I've read through and found that it's so important to know the proper pressure that is needed to occlude blood flow to prevent nerve and tissue damage. Now, unfortunately, there's not a specific answer that works for every individual. It depends on somebody's size, the size of their limbs, that kind of stuff. It's different for everybody. But there needs to be a kind of halfway point to where you're occluding the blood flow without causing nerve and tissue damage. So that's really important to know. Also, a lot of the people throughout the literature talked consistently about simplifying the process and making it easier for everybody involved to use the tourniquets. Obviously, if you're using a tourniquet, it's most likely some sort of emergency situation. So making that process as simple as possible for everyone is always going to be a good thing. And then the last part is there should be guidelines and standards put in place for tourniquet usage. That way we can kind of guide safe practice and make sure everybody is using them correctly. Okay. Let's see. So my three research questions that we were doing were, what ways can we measure how well the testing device is working? What are some ways that we can standardize the testing of tourniquets and determine whether they are actually effective at occluding the blood flow? And then lastly, how can we compare the internal pressure and the change in circumference. That's the circumference of the air bladder, which you'll see when I show you guys some pictures here in a second, using tourniquets with different cuff lengths. So the last one, unfortunately, we did not get to test the tourniquets that had the different cuff widths. We only got to test the ones that had the 1-inch cuff width, but we did still get some good data from testing the 1-inch cuff width tourniquet. So we set up 2 trials. The first trial was a set of weights that we kind of hung from a little contraption that we had set up. And we did one set of weights, and we did that weight 10 times. And then we moved on to the next set of weights. So we ranged anywhere from 40 pounds to 180 pounds. And like I said earlier, we tested each weight 10 times. The second trial was a continuous load trial where we started at one set of weights and then we kind of gradually increased the weight without taking the weight off and putting on a new one. So we did it from 20, we started it at 40 pounds and then we kind of increased in 20 to 40 pound increments and measured the change in internal pressure. I would have loved to have done these trials and tested different cuff widths, but like I said, we only were there for 6 weeks, so I didn't really get to get into too much of looking at the different cuff fabrics or cuff widths or anything like that. Here is a picture of our initial setup. This is kind of the very first iteration of what we had going on in the lab, and then eventually we came up with something like this where I don't know if you guys can see these little harnesses right here, but we basically suspended these 2 harnesses. One was over one side of this pulley system here at the top, and then the other was on this side. And we hung the weights on both sides. We tried to put them on at the exact same time to try and make sure that the tension was equal on both sides of the tourniquets. But that's the way that we ended up collecting our data with this setup right here. So here's some of the data. This is the data from the first trial where we put the weight on, take it off, put the weight on, take it off. We did this 10 times for each one. So here's the 10 trials for 40 pounds, 120 pounds, and 180 pounds. And then here is some of the data for our continuous load trial. As far as our results go, the measurements that you're getting for these is the pressure from inside of the air bladder. So that's this black device right here. We weren't really able to come to any conclusions because we weren't entirely sure that the internal pressure of the air bladder was actually a good measurement of how effective the tourniquet was. So like I said, it would be great if we could measure the applied pressure to the actual air bladder as opposed to the internal pressure. But it's great that we're getting some sort of data and able to look at what happens as we add more weight. So in terms of that, the air bladder is effective. Some of the limitations that we had for our research, we were only able to do this for 6 weeks, at least I was. I'm sure the rest of the graduate students in there are still working. But that prevented me from digging a little deeper into the setup and figuring out different ways to test the tourniquets. Also, the computer that I was using did not have the software that I needed to connect to the actual testing device, so I was really only able to do stuff while somebody else was in there, which kind of made it difficult. I couldn't really go in by myself and work on a whole bunch of things. I had to wait until there was a graduate assistant in there with me. And then just recommendations for the future. I would test with different cuff widths and different tightening mechanisms, and then potentially get a load buckle cell, which basically we would use that to measure the tension on both sides of the tourniquet and make sure that as we were adding the weights, the tension was equal for both ends of it. It wasn't just like pulling really hard on one end and not pulling that hard on the other end. So like I said earlier, results were mostly inconclusive. We didn't get to finish collecting enough data. Testing device was great for measuring internal pressure, but I'm not sure that the internal pressure measurements provide any useful data to determine whether the tourniquet is standard or effective or not. So transitioning into what my lesson is going to be, as you can see probably behind me, I'm planning on using some pool noodles, and I have some tourniquets in my classroom. What I plan on doing is doing a brief overview of the Clemson RET experience and kind of what manufacturing jobs are, that kind of stuff, and explaining what I was doing throughout my research, and then transitioning that into the main part of the lesson, which is going to be a lab activity where I have students use tourniquets on these pool noodles and kind of measure the change in circumference and see if they can get any cool data from that. After we do that, we're going to do a class discussion where we kind of talk about what are some of the pros and cons to this particular tourniquet model. Like, what kinds of things do you guys like about it? Was it easy to use? Was it hard to use? What do you notice that's happening to the pool noodles? Because the pool noodles are supposed to simulate like somebody's arm or something like that, that maybe they got stabbed or shot or something like that. So what are some pros and cons to this tourniquet model? And then the last part, what can we do to improve the tourniquet? Like, how can we make it better? Can we make the cuff length wider? Can we make the tightening mechanism easier to use? That kind of things. And I want the students to kind of design their own tourniquet throughout this process. And that's what they're going to submit to me, their own tourniquet design. And then the last part I want to go through is just some program takeaways. I've really loved the RET program. I've never done anything like this before. I'm kind of a new teacher, so I'm looking for ways to kind of expand out and get all sorts of new knowledge. It was a great real world experience that I can take back into the classroom with me and kind of show students, hey, there are avenues for you if you're not planning on going to college, or even if you are planning on going to college, like, here are some job opportunities that you might have not even heard about before. I think that was really cool to see all of those things in the manufacturing world. I also got a new perspective on research. I've never been part of research before. I didn't do grad school or anything like that. So that was something really cool to see actually happening and what that looked like. Program highlights. Obviously, I'm sure everybody's going to say this, but the trips, of course, doing all the tours of places that I would never step foot in had it not been for this program. I think that's definitely my favorite part of the trips. Also, just getting to know everybody, Molly, Chris, Dr. Johnson. I loved being part of like a group over the summer and doing things together and learning about each other. I thought that was really cool. How did RET compare to other PD? Obviously, I thought it was a lot better. It's a lot easier to do a lot more things when you're in a program for 6 weeks as opposed to just coming in for PD one day and sitting there and listening to somebody talk about things that you've heard 100 times before. So 100%, I would recommend this to other people. What do my students think? I'm yet to teach my lesson, but so far from the students that I have talked to about the different manufacturing jobs that I've learned about, they really do appreciate me coming to them with new knowledge and things that they can kind of take home and look forward to in their future, like potential jobs. Working, I know one kid was really excited to learn about the steel factory. He thought that was something that he would definitely be interested in the future. So the students love it. I'm really excited to do the lesson with them, and I hope they like it and are as appreciative and excited about it as I was about this program. And then last thing, acknowledgments. Once again, just thank you to everybody who helped me throughout this process. Dr. Kennedy, Dr. Frady, Dr. Johnson. I appreciate all of y'all's guidance throughout this whole research experience and giving me insight throughout the process. Even just something as low as making this presentation, I appreciate all y'all's feedback. Thanks to Clemson's bioengineering department, Dr. Desjardins, for helping me out and getting me started with the research process, and all the grad students working with them and everything like that. And that's it for my video.